lecture coincides with an online textbook at opengeology.org made by Salt Lake Community College faculty, including myself. And today we're going to learn about identifying minerals and how geologists do it. This is for introductory level material. So identifying minerals is relatively easy. As discussed in one of the previous lectures, there are well over 4,000 different minerals out there. And with a little bit of observation and a few simple tests, you can narrow down a lot of those minerals to just a handful of potential candidates. One thing to keep in mind is that for the most part, there's a lot of extremely common, there's just a handful of extremely common minerals out there. So I think I had to memorize a little bit more than 100 for my mineralogy class, which was a class devoted to studying minerals. And there's a few physical properties that that some minerals can tell you that are dead giveaways for that mineral. So first, let's talk about color and translucence. A lot of times, color is not a great indicator of the type of mineral that you're looking at. Take, for example, these different specimens of fluorite. In the bottom corner here, you have yellow and translucent and some green and some beautiful signature purple fluorite. Same goes for quartz. In fact, there's a whole slew of colloquial type names for different color variations of quartz. So, however, the amount of translucence, how easily light passes through that mineral, can sometimes be indicative of the type of mineral that you're looking at. And here's some of the words that we use. Opaque, meaning you can't see through it. Translucent, meaning it allows some light to go through it. And of course, transparent, like a sheet of glass, you can see through it completely. Luster is a little bit better of an indicator of the type of mineral that you're dealing with. And the first kind of major split that we do is metallic versus non-metallic. Does it look like a piece of metal? If so, we call that a metallic luster. And if it doesn't look like metal, and I'm not saying shiny, because there's lots of non-metallic lusters that are shiny, but if it does not look like metal, then we call that non-metallic. Here's a beautiful example of some quartz, that you can see there's a lot of glassy looking lusters happening in this specimen. So you can also have like an earthy luster, a pearly luster, silky luster, greasy luster. They're all kind of intuitive names for how the appearance of the piece, how it's reflecting light, not so much as the color, but the general texture appearance. Here's some examples. This galena cube here looks like a piece of metal. I would call that a metallic luster. Here's where you kind of get into a gray area, because this does look like rusty metal. We call this a submetallic or earthy luster, falls into the non-metallic category in view of most geologists. Streak is a little bit more indicative of minerals' true color. It's basically the powdered color, the mineral of the color of the powdered mineral. And you get these ceramic plates, which are fairly hard, and we'll talk about hardness in a second. And you try to powder the mineral on the plates, and you see what kind of color you get. Most of the traditional streak plates are white. And here's a piece of pyrite streaked across this white streak plate. You see it's kind of a greenish black color. Not every mineral will make a streak on a streak plate, and that's because of hardness. Sometimes a mineral cannot be broken down by the streak plates because it's harder than the streak plate. Sometimes if you can find crystals in the mineral, you can use crystal shape as an indicator of the type of mineral you're dealing with. There's a fibrous crystal shape, cubic crystal shape, botryoidal crystal shape, which is kind of like this bulbous look, hexagonal, Here, this is the classical hexagonal crystal shape of a quartz crystal here. Here's some fluorite. Of course, keep in mind that there's a lot of minerals that share the same type of crystal shapes. If you're willing to destroy your sample, you can test its strength and tenacity, how easily it breaks apart into smaller bits. The tenacity is its resistance to breaking or deforming. It's malleable. You can form it and flatten it very easily, like gold. Here is a very common test we use for identifying minerals, and this is known as hardness. This is how easily the mineral can scratch. And diamond is known for its hardness. It's one of the hardest minerals known to mineralogists, with the exception of a couple of minerals we found in much smaller quantities than diamond. There are a couple of naturally occurring minerals that are a little bit harder than diamond. They only occur in very minute quantities. The higher the number that we designate for the hardness, the harder the mineral. And a harder mineral will scratch a softer mineral. So something with a 10 is almost impossible to scratch. A fingernail falls about a 2.5 on the hardness scale, and glass is about a 5.5 on the hardness scale. And those are usually the two things I use to kind of bracket in the hardness of the mineral I'm working with. So here's the Mohs hardness scale, and here's different kind of minerals used to designate the different numbers on the hardness scale: talc, gypsum, calcite, fluorite, apatite, orthoclase, quartz, topaz, corundum, and diamond. Going from 1 to 10 is kind of an arbitrary scale, but it allows us to figure out the hardness of different minerals that we're looking at and helps us ID them. Notice that quartz is higher on the hardness scale than glass, and it's higher than fingernail. So if you can scratch a mineral with your fingernail, you know that the mineral is softer than your fingernail, softer than 2.5. Keep in mind that fake fingernails are a little bit harder than real fingernails. Cleavage is another really good indicator of what type of mineral you're dealing with. And cleavage is essentially how, the planes of weakness that the mineral will break along. So if you were to hit that mineral with a hammer, break it into tiny little pieces, it broke along certain planes, nice, flat, smooth sides, those are your planes of weakness. And you can be very descriptive with those planes of weakness, how many there are, in what directions, and at what angles do those different planes meet. And that can help you identify that. Here is an example of a mineral with one cleavage plane. This is biotite. Notice that it is breaking into thin sheets, and that is a classic one plane of cleavage mineral. Here's a couple of different minerals with more planes of cleavage. Fluorite, I believe, has 4 planes of cleavage. Calcite has 3, and they're not at 90 degrees, so it forms like a rhombohedron, a tilted box shape. But notice when this mineral is broken, it broke into smaller pieces that are the same shape. Really good indicator of cleavage. Some of the things I look for cleavage in a mineral is broken off pieces that are the same angles and shapes as the main surfaces that I'm seeing. And that's a good indicator that you're dealing with cleavage planes. You can also, the mineral is semi-translucent or transparent, you can look for where those planes kind of cut across the mineral. Fracture, if cleavage is absent, is also a good indicator to help you identify a mineral. And quartz is ideal for identifying fracture. Conchoidal fracture is kind of like that chipped glass appearance that you see when a rock hits something. Here is an example of conchoidal fracture. Here's some irregular fractures observed in quartz. This is a piece of obsidian, but you can also see this kind of conchoidal chipped glass appearance in quartz. Specific gravity can also be a good indicator of a mineral. And galena is an especially good example of something with a high specific gravity. Anything containing iron or lead, as galena contains lead, and it's heavier than it looks. And that's a good indicator that has a high specific gravity. Some other properties worth noting that some of the more common minerals have. Halite, if you're willing to lick it, is salty to taste. And there's a beautiful picture of halite showing its 4 planes of cleavage at 90, or 3 planes of cleavage at 90 degrees. Talc feels like talcum powder, soapy feel. Graphite has a greasy feel. You can write on paper with it. Some minerals are magnetic, like magnetite, creative name for magnetic mineral, and hematite, both iron-bearing minerals. Calcite can have a double refraction sometimes when it's especially translucent, but a more signature property of calcite is that it fizzes with dilute hydrochloric acid. So if you drop a couple drops of hydrochloric acid on it, it'll fizz profusely. And that's a really good way to identify it. So that's it for identifying minerals. I hope you learned something. And